Welcome to Bush to the Stars, the legal basics of Australians operating in space. We are thrilled to have you here with us today. My name is Jasmin James. I am a Senior Engagement Officer at the Australian Space Agency, and I will be your MC for today's session. I would like to extend a warm welcome to our presenters, General Manager of the Office of the Space Regulator, Krista Lewis, Senior Space Operations Assessor, Bron Hughes from our Regulatory Operations team, CEO of Robinson Aerospace Systems, Edward Robinson, and Skykraft's Deputy Chief Engineer, Simon Barraclough. Before we commence, we would like to pay our respect to the Kaurna people of the Adelaide Plains and acknowledge First Nations people as the world's first astronomers, who continue to preserve knowledge held in the Australian sky. We also pay our respect to Kaurna elders past, present, and emerging. This presentation will cover the basics of Australians operating in space, focusing on deployment and operations of objects in space. We will also hear from industry proponents who have successfully navigated Australia's space regulations. This session is an essential primer for anyone seeking to understand how regulations support safe, responsible, and successful space operations. At the end of this presentation, we will be holding an audience Q&A session. Please submit your questions via the Slido QR code on the screen. And without further ado, please join me in welcoming Krista Lewis, who will talk about why we regulate space.
Good morning. Hi, everyone. Thanks for being here. I'm just going to leave the Slido code up on the screen, even if you probably don't have a question now, but you might in half an hour. I won't have the code for you until right at the end. So if you'd like to just scan the code now and just leave it sitting on your phone, it should open at the Slido page. You can stick a question in at any time. It's really important to me that we're in a very open and transparent regulatory function in the Australian Space Agency, so please feel free to ask questions. Use it as an opportunity. Very, very briefly, I just want to recap the role of the Australian Space Agency. I think some people think it has a role that it doesn't have, or people assume it does things that it may not. In very simple terms, we have 5 core functions, and they're all related to each other, but managed in slightly different ways. One is to lead policy and coordination of civil space for government, so the primary advisor to government on civil space matters. The second is to shape and grow national space capability, including delivery of agency programs where they make sense to be done so from the agency. For example, the agency's RUVA program that you've heard this week is one example of that. The third is international civil space engagement for economic and strategic benefit in alignment with Australia's foreign policy objectives. Space is inherently international. It's a really great way for governments to work with each other internationally, so we work very closely with Department of Foreign Affairs in that regard. Fourthly is to promote a responsible space sector for current and future uses of space through technology, education and regulation, which is really the prime focus of the Office of the Space Regulator, which is a dedicated function within the Australian Space Agency and manages the regulatory function somewhat discreetly and separated from some of the other activities I've described on screen. And lastly is to promote the value and benefits of space to the community, including to inspire a highly skilled workforce. For example, we operate the Australian Space Discovery Centre out at Lot 14, just up the road. So talking to the regulatory function now, which is the only reason I exist in my role and my team, we've got 4 really primary goals about why we do what we do. And I should emphasise, I'm just going to briefly speak about why, and then I'm going to pass to Bron, who's going to talk about the how for putting objects in space, and then followed up by 2 companies that have graciously accepted the request from Andy Thomas Foundation to come and speak about their experience. So our goal from a regulatory perspective is to have a internationally recognised regulatory framework. Confidence in a regulator and a regulatory framework globally is really important. Some people may find regulatory frameworks and regulation frustrating at times, but it provides certainty about what is required So there's no doubt that systems can't be improved, but not having a framework in place creates far more uncertainty, particularly when working internationally. Second point is to enable entrepreneurship and sector growth. Third, assure risk to safety, security and national interests. That's really important. Remember I'm talking about the why? That's a particular focus of the questions we ask in the regulatory process. And lastly is to ensure Australia implements its obligations as a responsible space nation under the United Nations space treaties. Briefly, just on the legislation that exists, it's called the Space Launches and Returns Act. The previous slide that I just mentioned is basically encapsulated into the object of the Act. If you look at Section 3, there is a focus on safety, security, national interests, and to a degree, environment. So all of our engagement, all of our interactions with companies, if you're putting something on orbit, the questions we're asking should be seen through the lens of the object of the Act. Just briefly on Australia's international responsibilities, the number of treaties and customary international law. We're not going into the detail here, but there's 5 space treaties which the Australian government have ratified since the 60s, thereabouts, and various guidelines, rules and norms under those, including long-term sustainability guidelines. Artemis Accords, as many of you are familiar with, Australia was a founding signatory with the US, and various other mechanisms. In particular, the United Nations Copper Space Debris Mitigation Guidelines is one standard to meet for putting objects into space. The important thing to know from an Australian small business is that treaties and these international obligations are really ratified at the government level. Australian company X really doesn't need to know the detail of a space treaty. We implement our obligations at a government level through the domestic law. So if you meet your obligations under the law, that helps the Australian government meet its obligations under international law. It's a simple way of putting it. So it's useful to know this exists, but if it's not your prime focus, it needn't be. We've effectively covered that through the domestic law, if that makes sense. Just briefly on licensing volume is a really interesting metric that people are always interested in. This is a chart of licensing for all space activities under the Australian domestic law over the past 20 odd years. You'll see a rapid increase over the past few years. So this scope here includes launches and returns, satellites deployed overseas on foreign launch vehicles, etc. Some of you might have received a request for a survey about 6-8 months ago that some companies responded to. Obviously it was non-binding. We just asked the sector, what's your expected regulatory volume upcoming? And the response we get helps us inform government of future demand on the regulatory function. So if you're running a company and you happen to receive that request in the future, it's not binding, it's not mandatory, you don't need to reply to it, but it's very useful information for us to provide advice to government on volumes, etc. Because I think that's really important for us to maintain a rapidly moving regulatory framework. We need to be able to support the sector doing what it needs to do from a timeframe perspective. Just very briefly, just a graphic on what we call the space flight life cycle. Obviously you've got activities founded on the ground, particularly around pre-launch or launch, running launch facilities, etc. We're not talking about any of that today. What we're really talking about is just deploying objects in space. So for the purpose of this discussion, it's really focused on deploying Australian space objects in space on a foreign launch vehicle, which typically has been through rideshare vehicles, typically out of the US at this point in time. But we expect that to sort of evolve over time. If you're ever interested in seeing what has been licensed and what has been launched in Australia, it's all published on the Australian Space Agency website. There's a link on the card on your table if you're ever interested in looking at that. So under the Act that I mentioned before, there's various licenses, permits and authorisations. Really the scheme works on the basis of, it's called entry control. If you want to do something, you need to get something from a regulator to go and do it. So that's pretty much how that works. There's 6 broad categories of permits and licenses. They relate to launch, returns, overseas payload permits, etc. We're just going to talk just to a couple of those. So I'm going to pause there and pass to my colleague Bron Hughes, who's going to talk to Australian overseas payload permits and return authorisations. So if I just move back again, we are talking about, it's now not working, overseas payload permit, which is the licence in the middle, which is effectively putting an Australian object on a rideshare from the US, for example, on a Falcon 9 transporter or something like that. And also, that is the main focus. Just before I pass to Bron, she's going to talk to, sorry Bron, I'm just keeping you on edge. Bron's going to talk to the specifics of requirements that if you're looking to do an activity you should be aware of. I just wanted to briefly touch on the why, which I've done very, very quickly, but let me give you an example. We have requirements that ask for who you are, including your address, right? Why would we ask that? The answer is, I consult with national security agencies on who you are, such that you're not doing something nefarious in space. The answer is generally no, they're not part of the recommendation. It's as simple as that. That's why we ask these things. We don't ask things just for the sake of it. We use the information to form a view on a matter and then provide that recommendation to the Minister. So all of the questions and the requirements that Bron's going to briefly talk through all have an underlying basis of why we're asking. It's often lost and people sort of see it as a bit of a tick box exercise, but there's generally a reason for it. So what I'd encourage anyone going through the process, if you're interested and things are getting a little bit bogged down, ask the question, why? What can you help me understand why you're asking this? And I might be able to tailor the response better. So I'll leave it there and pass to my colleague Bron. Thanks, Bron.
Hi everyone, as Chris said, I'm Bron Hughes. I'm a Senior Space Operations Assessor with the Office of the Space Regulator, and I'm going to talk specifically about overseas payload permits and overseas payload return authorisations. So why would we want to talk about OPP and RA, overseas payload, when we could talk about rockets? Because what you see on the screen represents a fraction of the types of objects that have been permitted under Australian space law and launched into space by Australians. Since the introduction of the Space Launches and Returns Act in 2018, 34 overseas payload permits and 4 return authorisations overseas payload have been issued to Australian nationals. Some of those permits have authorised the launch of multiple objects under the one permit. So an overseas payload permit can cover anything from plant material being sent to the ISS through to geostationary communication satellites the size of a double-decker bus. But there are some things that we may not give permits or authorisations to for very specific reasons. The Act requires a declaration by the applicant that any part of the payload is not and does not contain a nuclear weapon or a weapon of mass destruction of any kind. Spacecraft operators will also need to make an undertaking that they will not operate their payload in a manner that causes Australia to be liable under any damage under the Liability Convention, and not operate the payload in a manner that the owner knows or ought to reasonably know will negatively affect the national security of Australia. If the payload is designed to contain a nuclear power source, the Minister's written approval needs to be obtained first and included in your application. If you are considering the inclusion of a nuclear power source, please talk to us early because we need a little bit more time to consider your application. So, you will need an overseas payload permit if you are launching your object overseas. Your object will go whole or part of which beyond a distance of 100 kilometres above mean sea level, even if it only goes part way to 100 kilometres. This includes payloads that are contained with suborbital launch vehicles, even if the payload does not leave the suborbital launch vehicle. Or in the case of experiments going to the ISS, objects that will remain on the ISS. Lastly, your object is owned by an Australian national, as defined by the Act. For return authorisation, it's very similar. The object is being returned overseas. The object is being carried by a payload by another space object, such as a hosted payload or something returning from the ISS on, say, a Crew Dragon or a Cargo Dragon, or contained within a capsule such as the Nix capsule, which launched on Transporter 14 recently. And lastly, the object is owned by an Australian national as defined by the Act. The requirements to be met for an overseas payload permit are set out in Part 4 of the General Rules. The application guidelines for an overseas payload permit step you through each of these requirements. The requirements to be met for a return authorisation overseas payload are set out in Part 5, Subdivision B of the General Rules. The application guidelines for return authorisation overseas payload steps you through each of these requirements. Both sets of our guidelines are available on our website, and we encourage you to read them before you commence an application. And if you scan the QR code on the business card that's on your table, that'll take you directly to that page. Something that we get asked a lot about is debris mitigation. You will be required to provide a debris mitigation strategy as well as an orbital debris assessment report that is based on an internationally recognised debris mitigation standard or guideline as a part of your overseas payload permit application. It is up to you which international standard you use. The requirement to have a debris mitigation strategy and an ODA applies to all Australian-owned payloads travelling beyond 100 kilometres, including suborbital flights, hosted payloads, payloads travelling to the International Space Station, the Moon and other celestial bodies. In some circumstances, the chosen standard or guideline may not apply in its entirety to your payload, and where you feel something doesn't apply, please provide evidence and a statement of this in your application. We can have a chat to you about it. Your debris mitigation strategy can align with the launching company if it's clear which parts of the strategy apply to your payload, along with any supporting evidence. Our ideal journey path would see applicants considering debris mitigation strategies and end-of-mission disposals at the concept, design and review phase of their mission. By implementing mitigation measures early, spacecraft operators can minimise the generation of new debris, reduce the risk of on-orbit breakups and facilitate the eventual safe disposal of spacecrafts at the end of operational mission life. This proactive approach helps safeguard current and future missions, protects critical space infrastructure, and preserves the space environment for all. Integrating debris mitigation and having consideration to the regulation in the design phase could also reduce the risk of having to retrofit your spacecraft or mission to meet regulatory requirements. Some tips and tricks. We need to receive your complete application at least 3 months prior to payload handover and shipping preparation. Speak to your launch service provider as they will be able to advise their payload preparation timeframes and customer deliverables. We require your roles and responsibilities, as Chris mentioned, people in key roles associated with your activity. You can you can list as many launch facilities and launch vehicles in your application as you like. We can include these alternate sites and vehicles in your permit. You need to provide the launch purpose and launch safety information for the combination of the facility and launch vehicle and the regulatory frameworks under which they operate. Oops. As mentioned, it is a requirement under the legislation to provide a debris mitigation strategy based on an internationally recognised guideline or standard for debris mitigation. Please talk with us if you are unsure how to meet this. Consider your insurance requirements and your financial requirements for your proposed activity. You may want to seek independent advice on your insurance needs, especially when shipping something as your baby overseas to a launch provider. You will need to see your contracts. We will need to see your contracts for launch from your launch service provider. Please discuss with us if you have concerns about sharing confidential contracts with the agency. You may have requirements under other legislation and regulations, for example, defence export control. Satellite filing and coordination processes can also require extended timeframes. So we recommend that you contact the Australian Communications and Media Authority early if you are looking for that kind of filing, spectrum licensing. If your activity has particular complexities, such as the inclusion of a nuclear power source, you're creating a time machine, and it's first of its kind technology, we may need additional time to assess your application. But if you do invent a time machine, please let me know. If you are granted a permit or an authorisation, we will include your permit and authorisation details on the Register of Ministered Decisions about space activities on our website. You will also have obligations after your object has been launched, including notifying of orbital parameters for your space object and communication establishment if your satellite is deployed into orbit. We will provide details of your payload and its orbital parameters to be included on the United Nations Register of Objects Launched into Outer Space, and we will also update the Australian Space Agency's Register of Space Objects authorised under the Act and also found on our website. You may have other conditions associated with your permit, and that will be particular to your payload and your space activity. So, if you scan the QR code or you scan it on the business card that is on your tables, this will take you to the Permits, Licence and Authorisations page. We will have some of those business cards downstairs available as well. So you're going to talk to the regulator, right? Please? Just soak it in, people. We encourage early engagement with the Office of the Space Regulator. Not only do we want to hear about your exciting space activities you have planned, but we also need sufficient time to assess your application prior to your planned activity. We also are happy to receive draft applications well ahead of your proposed activity and date, and work through any iterations and materials and queries that you may have. We kind of see it as a collaborative process. The Minister responsible for civil space activities also needs sufficient time to make a decision on whether to grant a permit or give an authorisation. Aim to have your completed application to us 3 months prior to payload handover and integration, or more than 3 months if there's additional complexity with your activity. You can contact us via regulation@space.gov.au, via our space operation assessors such as myself for your ongoing application needs, or via the regulatory engagement team. Thank you everyone for your time. Now please join me in welcoming Robinson Aerospace Systems CEO, Edward Robinson.
Awesome. Hey everyone, I am Edward Robinson, the founder and CEO at Robinson Aerospace Systems. For those who don't know, we're a STEM education company, and we deliver STEM through space, because what's more exciting and inspiring than space? And what we do is we work with kids to launch student-built experiments into space on SpaceX rockets. So in the early days of the business, about 3 years ago, we were making replica satellite kits that kids were using in the classroom. The kids loved building the CubeSats, doing experiments, but we eventually decided that if we're going to say these kits are replica satellites, then how do we know they're replicas if we don't actually put something into space? So that kicked off the idea of actually doing that and actually launching to space. So eventually we found a launch provider and we got all of the systems in place to actually make this happen. And inside of it is student-built experiments. So a few main things. There were experiments from kids from 7 different countries, with kids as young as 11 involved in the project. So a lot of experiments inside. Project Space Cool had kids from Rwanda, Singapore, Colombia, Ukraine, UAE, USA, and Australia, of course, all building experiments that we would put in space in this little tiny CubeSat. So we're working with a lot of countries here, which adds some complexity to things, but there was ways to simplify that in the process. Now, we had a very unique mission profile, and that we had the CubeSat payload was mounted in the unpressurized cargo of a space capsule that was being built in Germany. That space capsule was then shipped to California to go into the SpaceX Falcon 9 rocket. So a lot of countries involved with this thing. We've got the schools around the world, we've got the German-built space capsule, and we've got the US-built rockets. The mission was very unique in that it would go up into space, The space capsule would stay attached to the SpaceX rocket on the SpaceX Transporter 14 mission. The SpaceX second stage would eventually do its deorbit burn, and then after that it would deploy the capsule on a trajectory to re-enter somewhere between Alaska and Hawaii, I believe. So only in space for about 3 hours, but whether it's 3 hours or whether it's 3 years, the process is still the same. What is that process? Well, step one, which I actually forgot to put on there, was to go to the website. Most of the information you need to find, we found on the agency's website pretty easily. And we quickly worked out that we needed the overseas payload permit to be allowed to launch it, and the overseas payload return permit to actually get it back from Germany in the event that it would successfully return from space. After that, I reached out to the team and I said, hey, we want to do this. Here's the basic details. What can you tell us about the process? And the reason for this is our first launch. And our team is essentially just a group of university students working with high school students. Right, so this process was a little bit scary for us. It's like, what is the agency going to think about this group of uni students trying to launch this thing into space when you compare us to these much larger companies that have been doing this for a long, long time. But that didn't seem to slow us down, wasn't an issue, and there was plenty of ways to work around that. But yeah, first met with the team just on video call because the team's all around the country, and just learnt the basics of the process. And the process seemed pretty simple at the time. It was literally download the application forms, fill it out, and submit it. So we did that. We submitted the overseas payload permit and the return permit. The best part is these things are free, which for a startup like us is a very big deal. There wasn't going to be like $20,000 in application fees for this or something like that. It was all free, which really helped us a lot, and we're very appreciative that it is a free service. After that, there was some questions that came back to us after we submitted it. Just some areas that they wanted some more clarification to make sure that we're doing things properly. Those main areas were around things like ownership. If it's being, if there's student experiments around the world and we built it, like who actually owns it, right? Who are the key personnel involved? Who are the key, engineers managing the project? And where is the return area that's actually going to splash down in the ocean? These are all things that it was pretty easy for us to find this information just by having a chat with our launch provider, the exploration company who was building the space capsule over in Germany. The sort of information we required for those was nothing that we wouldn't expect. It was all stuff that you should pretty well already know and be able to find pretty easily about what your launch is. There was a few things that were a bit vague, like exactly how long would it be in space for, and that was okay because the permits that we received had some flexibility in the exact details by the time it actually launched. We did, of course, get on to doing these permits quite early. We didn't leave at last minute. If you try and get a permit a week before launch, probably wasn't going to happen. This is government after all, so got to give them a bit of time. So I think from the time that we actually first contacted them would have been in the development phase, just to make sure there was nothing that we should know that would impact development. And then from the time we actually finished talking to the permits going through was something like 3 or 4 months, which isn't too bad. And there's ways for them to speed it up if it is a little bit urgent, but we don't want to put that kind of pressure on them. So there was also the debris mitigation strategy. This for us was the most complex part. When I first heard about this, it's like, the hell is a debris mitigation strategy? What is that? But you do a bit of research, kind of a few hours of research, and you realise that it is a thing, and there's plenty of resources out there. For us, because we're attached to the space capsule, we don't have much choice what happens to us. The space capsule is in control. So that was just a case of talking to our launch provider and saying, what kind of standards are you following? And then providing a little report that we wrote up that had, our launch provider's following these standards. Here's a few other areas of justification, just to make it clear that if something does happen, it's not our fault. And the likelihood of something happening is very, 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 very slim. So there was no problem there. And the United Nations registration, signing a thing that says we're not launching nuclear weapons was interesting. Obviously we're not, but still got to sign that. I thought that was kind of funny, but that was cool. And eventually the wait begins. We finished emailing all the questions and stuff, and they're like, oh, yep, just got to wait now. And I was kind of like, that's it? That seemed too easy, I was expecting a much bigger process, and so I was actually quite shocked how simple that process was. And then it was just a matter of waiting for that to come, and eventually get this nice little thing signed by the federal minister which we've now displayed in our little display case back at the workshop, which is a pretty cool little souvenir to have. Yeah, overall it wasn't too difficult. Once you get through that process and you wait for those permits to arrive, eventually you have approvals and we can ship it overseas to Germany. They put it in the space capsule, that goes overseas to California. And about 3 weeks ago, we finally had what was by far the most exciting day of my life. And I've got a little video just to kind of capture that moment.
Well, a satellite designed by a 21-year-old Australian is officially in orbit after a successful SpaceX launch in the US.
It will perform experiments designed by students from 7 countries, encouraging kids to dive into science.
5, 4, 3, 2, 1, ignition. And liftoff of Falcon 9. Go, SpaceX, go, transport 14. Vehicle switching down range. Stage 1 landing confirmed.
Get a little tear in my eye when I watch that. Thank you. That's a pretty special moment. That's dreams truly coming true. So yeah, that's awesome. But back to the topic at hand. The moral of the story is if you can figure out how to put something in space, the permits are probably the easy part. As long as you give them some time and you give them the information they ask for, which is all logical stuff for them to ask for, the permits are not too difficult. Of course, there's some outliers. If you're someone like Gilmore Space launching an orbital class rocket from Australia for the first time, that's going to be a bit more difficult and take a bit longer. If you're sudden launch doing returns, the dangers of that are quite a lot more extensive. So for what we're doing, just putting something in space, that's been done a lot of times. The process is very laid out. Yeah, there is some more difficult situations where there's returns and rockets actually being launched in Australia. But yeah, that's all from me. I will now hand over to Simon from Skykraft, who will talk about their experience in launching much bigger and more complex stuff than us. Thank you.
There it is, yep. Hi, so my name's Simon Barraclough. I'm Deputy Chief Engineer from Skykraft, a company based in Canberra. One thing's interesting, just before I go into this, I've been in the industry for some time now, 10 years in Australia, a lot longer in Europe. And just my mental maths just now is I must have submitted 15% of the applications for licenses over the last 10 years. So I've done five, so I think it comes out about that. So Skykraft is, we're what we call a space infrastructure company. So essentially what we aim to do is provide services from space. So essentially collecting data from space and providing it to customers on the ground. So very much constellations as a service. Our first mission is all about air traffic management and air traffic communications. So tracking aircraft around the world and pilot cockpit comms to the ground. And this is all about making air traffic management more efficient, allowing aircraft to fly, providing more surveillance of where the aircraft are. If you look on flight radar, for example, as the aircraft goes over the Pacific Ocean, the line turns black. It's because we don't know. We don't have the ADS-B receivers out in the ocean. So we are all about shifting those receivers above rather than on the ground, and then providing global coverage. And so that's our first sort of launch customer. That's what we're looking to develop that constellation. In that, we will require a lot of spacecraft. And that's why we talk to the Office of Regulation and sort of keep them aware of what we're up to. Oops, I've got to point straight at the screen. So to date, we have various spacecraft we've launched already. So we did have what we called Skykraft 0.5, which is a single spacecraft, which you can see at the top right there. That was a very early prototype of the technology. It was also in the days when we thought we could do our service with a much smaller spacecraft. And as our requirements have grown and as our understanding grown, we're getting bigger. Unfortunately with that one, our launch service provider unfortunately had an issue, and so we weren't able to launch that one. But also, at that time, it didn't matter. Our technology had moved on by then, and so really, it didn't need to go to space. We had learnt enough from what we did on the ground to then apply it to the next ones. And in fact, that model there, which is actually hanging from our ceiling in the office, is going to the Powerhouse Museum in a few months to be hanging from the wall over there sometime soon. But if you do see it at the Powerhouse Museum, it was qualified to go to space. It just didn't make it there in the end. Then we have 2 more stacks we launched, Skykraft 1 and Skykraft 3. Don't ask why the numbering skipped 2. Anyway, there was reasons why we skipped numbering, but essentially 2 different stacks of 5 spacecraft, launched about 6 months apart over 2 years ago. Of the first stack, 4 are still in orbit. 1 has deorbited only recently. And of the second stack, 3 have come down. And this is all down to this different ballistic properties of the spacecraft and ways they operated. We deployed some things on some and not others. So and also ended up at different altitude as well. We go on rideshare, so at the moment we don't dictate the altitude. We sort of pick one we like, but we don't say exactly which one. And so sometimes you're higher and lower, and things come down. Also, what was noticeable as well, the sun went a bit crazy. The sun is certainly a lot more active than it has been for a while, and it has been quite happily deorbiting our spacecraft. That being said, I'm quite happy about that. Those spacecraft have done their job. They did our tech demonstrations. We learned what we needed from those. And to be fair, I like to see them come down. I get quite annoyed. All the messages I get from collision avoidance warnings and things like this, it's nice to see them disposed of when they've finished their jobs. And so what we have next, I don't get so excited over this, but a lot of people at Skykraft get very excited to say that in the 2 launches we did, those 2 stacks, we tripled the amount of mass Australia put into orbit. I don't know why we judge what we do on mass, but anyway, that's people like to talk about that. As I said, the next we have what we call Skykraft 4 coming up very soon. So it's another stack of 5 spacecraft. That is going to be extremely soon. So I can't unfortunately say the date, but it will be very soon going on there. And it's sitting out in California at the moment waiting for that. So Skykraft 4, the ones that are going very soon, they're about 300 kilograms total launch mass, just above that 320. Of that, 250 will actually be deployed into orbit as 5 spacecraft, which all vary in mass. So some are 35 to 60 kilograms. Main reason for this is they're doing different things. They're all part of our technology demonstration for our eventual constellation. And so part of that, some need more things than others for the different tasks we want to do with them. So there's a range of different ballistic properties with those, areas and things like this. So they all have to be assessed in our ODAR analysis to cover the range of things that might happen as they orbit the Earth. Features that we had to think about in the process, sorry, I should say, you can see in the photos there, to get a sense of scale, the photo on the top right, that is the Skykraft 4 stack sitting at the Vibe test facility. So it's hard to judge scale, but that's because it's a few meters behind us, but it's a meter by meter by meter cubed. And it sits in what this is large dispenser. We can see the word Skykraft written on the side. And so 5 spacecraft project out of that. What was interesting to note with that when it comes to SpaceX, we had to explain this dispenser. So what we found, not many people develop their own dispensers. And we made our own because we had to for our design. And so we had to work a lot with SpaceX. And that was actually that's another discussion for another meeting, how to work with your launch service provider. But get across the line that. What was amusing about that one is they trying to get their head around it and basically came to the conclusion, it's just a very large CubeSat dispenser. And yes, it's a 1,000 U CubeSat dispenser, if you want to put it that way. But essentially, they were happy understanding that. And what you can see just below that was from the Australian Air Show, you can get a sense of scale. The spacecraft are about meter by meter by about 20 centimetres high. But they will deploy antennas and solar arrays and get to quite a large size. The things we have to think about, this is more of an LSP requirement, but we need to stay conjoined for 7 days. They have a responsibility themselves for when they launch us, they have to propagate us and make sure they do not deploy us into an orbit that will collide with somebody else. And that sort of liability covers them for 7 days. So it restricts how we operate. So for the first 7 days, we have to stay as a stack and we can't separate. We sort of tumble and wait for that period of time, talk to spacecraft, just get some initial telemetry, make sure we did actually deploy and we're healthy, and then separate after that. And so it has design drivers on us that we have to consider and will continue forever because it's always going to be a requirement from them. But other things we have to consider, which we've worked a lot with the Office of Space Regulation about, is particularly our thruster. So our thruster is in development. We eventually, for the constellation, to maintain our constellation in position, or the spacecraft position, they have to be thrusted. Drag and other operations, things like that will propagate or distribute the spacecraft apart from each other. So we need to thrust to keep them together. We also need to thrust to adjust our orbit. And so that's very much in development. Last spacecraft, unfortunately, did not have a thruster. They were too early for the thruster development to be able to fly that. But the next 5 will. And so what we have to look through there is how we operate the thruster. But it was interesting in terms of our compliance to the regulations. We certainly never stated that we were going to be compliant by using the thruster. It's too much in development, it's too new. For us, we felt that for us to say, yes, it'll be fine, our thruster, it will work great, then we'll be compliant, was not the way to go. We wanted to say, no, in a worst case scenario, if things haven't quite worked out, we will still be compliant with what's required with our design and our circumstance. Other things we had to work about, and this is the thing sort of later, is a carbon wound tank. So we have a pressure tank on there, and there's some issues with that in terms of the carbon fibre winding on that, and so a lot of discussions about that, which I'll go through in a minute. So the big really work for us was the ODA, the Orbit Debris Analysis Report. So modelling things, we used ESA Drama. So the main reason for that is my experience in Europe was using that tool, so it's an easy enough system to use, so we use Drama. And due to our stack configuration and multiple spacecraft configurations and multiple deployables, we had to look at lots of different cases with that, all to assess that deorbit time to make sure we were compliant to the requirements. And as I say, we rely currently to be compliant as on passive deorbiting. It will basically drag down. And as we found with our current spacecraft, they're coming down reasonably quick as well. Other inputs to the process were quite routine. One thing we did have already, which made the process this time easy for us, was we already had our existing RF licensing. So licensing was performed for earlier spacecraft. For this one, so I can't comment on Skykraft for that one. I would say, though, for Spirit, the Australian Space Agency spacecraft that when I was at University of Melbourne was leading, on day one we were officially able to announce the spacecraft. Day 2, I rang the ACMA and said, look, all right, this is coming up in 2 years. What do we need to do? My response from the ACMA at that time was, you're already too late. So anyway, it was fine. We got there in the end. But yeah, this stuff does take time, and you've got to really factor that in. So which as we worked through on the ODAR was the tank. So our tank is covered in carbon fibre. The analysis has some limitations on that because it assumes carbon fibre will survive re-entry. So it's some interesting discussions to be had about how we model this, what's the risks of this, what's the reality of that analysis. So there's a whole lot of work we went through that to understand the risks of a tank re-entering and hitting the ground. Our thruster, being a micropropulsion thruster, has some high temperature materials in there, so we need to look at that and what that means in terms of survivability of the ground. And also, what we also had, that large dispenser, it's some 70 kilograms of mass. That's a large amount of hardware that is returned to Earth by SpaceX. So they will re-enter that, because we obviously don't stay attached to it, they will re-enter that. And so what does that mean in terms of the regulations? Because we now have a large amount of mass being returned by another party. And so there's a lot of work we discussed with the agency about the implications of what that might mean. And also, as always, we're rideshare, so there are changes to launch and deployment altitudes and things like this. So there's a lot of back and forth with the OSR about that. So in terms of the process, I think it's important to remember the Space Agency really does want us to get stuff into orbit. They're not there to try and stop us at all, but they need to work within the bounds of the regulation. So you've got to be considering that they have to work with other parties and other things outside the space industry who aren't so excited that space is cool. They're not really going, great, let's just do it. They've got other bounds and other concerns. So we have to work with them to help them explain us circumstances to other people who have to approve us. And that's an important thing to remember, that they are behind us, but they have their own bounds. What went well, open discussion with the Space Agency was very important. We tried to involve them as early as possible. So we were about 18 months before we launched on that one. I think even then, we would go earlier next time. We also, one thing I really would like to value here is for our review of our ODAR, there was a lot of feedback required, well, a lot of review of the technical work in there, and the agency involved an external company to review our work. And actually, we very much valued that because they taught us things we didn't know, which will apply to next time. So there was a lot of good interaction with that, a lot of back and forth, a lot of meetings, but actually it was very useful to us, and we appreciated that. What we could do better next time is say, well, for other people, the RF license they mentioned, get there early. Discussions about plans, we will, as I mentioned before, we will talk earlier to the agency, and we will keep talking. We'll always keep them involved in what we want to do. And also, for academic interest anyway, but also if we do change our pressure tank, we'd like to understand better how we model pressure tanks and how they break up. And looking towards things like the design for demise. And also this thing about the stay-behind hardware, the large dispenser we have. What is the future complications of that? And one thing we will have to consider in future is that the industry will move on to things like Starship. What does Starship mean for us in the regulations? And that's it. Thank you very much.
We would now like to invite you to participate in our audience Q&A. This is your opportunity to engage directly with the presenters and ask any questions you may have about their presentations or any of the topics that you've heard about today. If you haven't already, please take the opportunity to submit your questions via Slido. So I'm just opening up the Slido now to have a look at all the lovely questions that I'm hoping that you have inputted for us. All right, Bron, I might throw this one to you. The question is, what is the process the agency follows when dealing with confidential information in contracts disclosed to the agency in an application? So I'll...
It's a question that we get asked a lot about, and my instant response is the government is a locked vault. When your information comes to us, it comes to us under a legal framework where we can only ask for things that are relevant to what you're applying for. So as Chris mentioned earlier, we don't ask for things that we're not allowed to have, but the side note to that is we're also not allowed to share your information outside of its purpose being delivered to us. We do have a lot of people asking us, well, we've got a confidential contract with a launch service provider. They don't want to provide that contract to you because they don't know you, they don't necessarily trust you. How do we work through that? So a couple of the things that we tend to look at is, can you provide us with a version of your contract that might be slightly redacted? The issue with that is that if you provide us with something that's redacted, we may come back to you and say, you've redacted too much. Can we have a little bit more information? The other thing that we can offer is that we can talk directly to your launch service provider if they feel more comfortable providing it directly to a government agency. We can also talk to them about our privacy principles and what we're governed under in regards to the protection of your information. I think the thing I really want to stress is we guard your information and we protect it because we understand that you are providing us with sensitive information about really, amazing technology that you've developed and that you've worked on, and you're also working with launch providers that want to protect their information as well. So we just want to make it clear we're not asking for it so that we can then post it on social media. That's not its purpose. Do you have anything to add to that?
Yeah, just briefly, you recall I mentioned the 5 roles of the agency at the start. When you're engaging with the regulator on regulatory matters, it is for the purpose of regulatory matters and no other reason, as Bron said. So you may well have a grant application with the government in relation to the same proposal. Those two processes don't talk to each other at all. It's by design. You may say, can't you just share information? I won't have to say the same thing twice. It's for the reason that Bron just spoke about, because information goes places that shouldn't go, creates risks. So the Office of the Space Regulator within the Australian Space Agency maintains quite a separate, even just getting very tactical for a second, document management framework. Information is not shared across for multiple purposes. So it's very important that you have that confidence in that system. I'd also just add our interactions with foreign regulators. So obviously there's overlaps here with people who are talking about SpaceX Falcon 9 in particular, regulated by the US government, by the FAA, AST, etc. There are working relationships at the international level across regulators, but generally you don't get credit for things. But what we try and do is not overstep the mark, and we recognise that a foreign regulator is looking after the launch and the deployment, for example, so our questions will usually stop at a point where we then rely on the foreign government's regulation of the whole activity from a launch perspective. So that's another thing that we consider, but again, we don't share information across governments like that. We would never do that without the proponent being involved in the process.
Thank you for that. The next question is for Edward. The audience would like to know, how was it collaborating with international students to create experiments for your CubeSat, and did that add any regulatory challenges?
Yeah, so I wouldn't say it added any challenges. For us, it was just working with them quite carefully to make sure that they knew what they could and couldn't do. These are high school kids as young as 11, so there's a lot of stuff that they don't know about, how to properly design things for space, and how to manufacture things for space and program it for space. So it was just a careful process of making sure that we do work closely with them to make sure they know what they need to know. We review design to make sure that things are all good. It's one of those things that kind of sounds crazy at first, like you're going to put school kids' experiments in space, but there's really no reason that it can't be done as long as we just make sure that they're doing the right thing according to various documents that we've been given from our launch providers.
Thank you for that. This might be another one for Bron. Does the Space Regulator guide applicants through contacting other relevant parts, I'll rephrase again. Does the Space Regulator guide applicants through contacting other relevant parts of government, for example, export controls?
Another really good question, and I think Chris has said this a few times, and a couple of my other colleagues. We try and have a bit of a you are coming to the door of the government, so we understand that we are a shop front for the government, and where we can, we will try and collaborate with other government parties to make sure that we understand what other regulations are out there, but also assist you to connect with those other government departments as well, so that you're on the right track and that you're getting what you need to do. We may not necessarily be in the room with you or assist you with that process, but we could certainly look at getting you to the front door and making sure that you're talking to the right people for your particular activity. Did you have anything?
Yeah, I want to make sure it's crystal clear, considering our response to the previous question. So we don't share information across government for the sake of it. The information is used for the purpose of what you ask for. So if you ask for a license for an OPP, for example, we will consult with national security agencies on who you are. They will give us an answer. We will then form that into our assessment and finish the process. We don't just share information for some other reason. So that's just to make the distinction. It's for what did you ask for? It's in your interest that we consult across government on various things, because that's to achieve the outcome that you asked for, but we don't consult on any other matter. Where it starts moving into sort of other matters, we will do introductions, we'll do meetings. We've got a whole engagement team that's developed for that to try and facilitate a sort of a single front door, but at that point we'll probably step out of it because it's not our process to manage, if that makes sense.
This is probably an open question to all of you, but are there consequences for non-compliance of a permit?
Yes. No, sorry. I'll start and I'll pass to these guys. We don't use a big stick. We understand it's a new industry and we want to encourage the right behaviour opposed to punishing things that aren't necessarily right. So we will have conditions on your permit and we will remind you of what those conditions are when we issue your permit to you. We may contact you at various points prior to launch and after launch just to check in and say, how you going, what have you done, where's things at. If we discover that something's not quite gone the way it's supposed to on the permit, we will have a chat to you about it. We might have a friendly discussion about how did this happen? Were you aware of it beforehand? How could we have mitigated that prior to it actually occurring? And one thing that would probably spring to mind with regards to that and what I mentioned in my presentation is we have a lot of applicants that will say, I'm going on a Falcon 9 via Transporter 14 and it will be launching from Vandenberg. And then we find out that the launch a few weeks out has been moved to Kennedy or somewhere else, or they've come to us and said, well, actually, we found a spot on Rocket Lab and we want to go with them, and it's already gone. No, that didn't happen. So what you need to think about is the whole picture, and if we say to you, are there other vehicles that you could potentially go on, or are there other launch sites that you could potentially go from? That's because we've had experiences that those things have cropped up, and we're trying to make sure that we're guiding you and helping to mitigate that possibility that you could become non-compliant with your permit. Who would like? No?
Very simply for us, we want a long career, a long history in working in this space. If we don't, well, the consequences for us is, well, you guys won't sign the permit, and our launch service provider will not launch us without that. So we are very actively aware that we need to work with the OSR in terms of what we're doing, how we're behaving, that it is within the bounds that these guys have been defined, is that we have to follow. But as I say, it's not that bad. You just got to think about it and consider what you're doing.
And this is all we have time for today. So I would like to extend a heartfelt thank you to our presenters for their insightful contributions, and to all of you for your participation today. And we hope that you enjoy the rest of the forum. Thank you very much.